Hi, everyone, and welcome to today's ILTA webinar, Avoid the Top 10 SQL Server Configuration Mistakes for Performance Success. I'm Gail Kelly, and I'll be serving as your moderator. Our speakers today are Ted Theodoropoulos, the founder and president of Acrowire, a legal technology consulting firm where he combines his interest in technology with his passion to improve and transform business operations, and Ben Debo, the founder and CEO of Fortified Data, who is an experienced consultant working with customers of all sizes on their mission-critical applications and SQL Server deployments. I would like to thank Acrowire for sponsoring today's webinar. Our presentation will run about 45 to 60 minutes, and please submit all questions to the Q&A box. If those are not answered during the presentation, they will be addressed at the end. Before we start, please know that we are recording today's webinar, and we'll post a link to our website under recordings shortly after today's presentation. I will now turn over the webinar to Ted and Ben.
Thank you, Gail. This is Ted Theodoropoulos. So I want to thank everybody as well for taking the time to listen in on our content today. We're going to talk about 10 things to avoid with respect to SQL Server configuration. As most of you know, SQL is a big back-end platform for many legal IT systems, as well as SharePoint and custom applications that may be deployed within your firm. So a very relevant topic, and the content here is primarily presented by Ben, who does a great job. So what we're going to talk about today, Ben and myself are going to do some quick introductions. We're going to conduct a poll to figure out exactly, we're going to tailor the content based on the types of roles that most of you have. We're going to go through SQL performance goals, trying to explain how, what you're trying to accomplish very much plays into how you go about configuring SQL. And then we're going to look at best practice versus real world. And there's always a big gap between, what's defined in the ivory tower and what happens on the ground floor. We're going to talk about top operating system misconfigurations, and then we'll summarize and do a quick Q&A. So I'm Ted Theodoropoulos, founder and president of Acrowire. Been in the IT world for many years. Started my professional IT career on the SQL Server team at Microsoft. So I have a lot of background in SQL. We do a ton of work in legal IT, so very familiar with many of those systems, as well as project leadership and custom app dev. And I'll let Ben introduce himself.
Thank you, Ted. I'm the founder and CEO of Fortified Data, and we're a firm that focuses really on designing, supporting, and managing database platforms of various types. I personally have had my experience with SQL Server for about the last 20 years, so I've been around it for a very long time. And then I specialize realistically working with organizations on scaling, designing, and HADR and cloud deployments. Basically, what does it take to get your application running at optimal performance, scale, and reliability for your mission-critical applications. The other thing that I do have a passion for is barbecue. I'm a South Carolina barbecue judge, so that's a little bit of a FYI for me.
Okay, thanks, Ben. So I mentioned that Acrowire focuses on legal IT, and from a capabilities perspective, these are the different practice areas that we focus on. So SharePoint, we really do pretty much everything SharePoint, from custom development to farm implementation. There's really not much in the SharePoint world that we don't do, and we deliver more SharePoint services to legal than anybody else. We also do custom app dev, so this may not have anything to do with SharePoint, just standalone bespoke development, primarily on the Microsoft stack, but we do some outside as well. And then envisioning. So many times when we engage with law firms, there's a very kind of nebulous conceptual picture of what they want to accomplish, but the picture isn't quite clear enough to get granular on things like timeline, scope, cost, budget, those sorts of items. So we send clients down the envisioning path to really help flesh those things out and get them in position to really plan properly. And then SQL Server. I mentioned I'm a former member of the SQL team. We partner very closely with Fortified Data, which is Ben's company, and we do everything SQL. So from a managed services perspective, Ben talked a little bit about scaling SQL, ensuring proper configuration. We have a product called SQL MD, which we'll tell you about at the end, which is a current state analysis, and then of course migrations and upgrades. So Gail, if it's okay, let's go ahead and do the poll so we can figure out kind of where everybody's role is, so we can focus content accordingly. So if you wouldn't mind responding to this poll and kind of tell us, are you a DBA? Are you responsible for managing SQL infrastructure? Are you a developer? Are you writing stored procedures and views and implementing schemas and those sorts of things? Or are you on the infrastructure side? So managing the OS, the hypervisor, storage, the VMs. If you wouldn't mind indicating where your role most closely aligns. And then of course, if none of those three really fit, you can put other. But this will help us bring the level of detail up or down based on, what you guys are responsible for. Give you another few seconds to get those in. Then how are we looking, Gail? Do we have a breakdown? Okay. So it looks like 43%, which is the largest category, are DBAs, followed by infrastructure, 31%, and then developer, 14%, and other 12. Okay, so good. I think this content, the way we normally deliver this content, is very well suited for that audience. And with that, I'm going to turn it over to Ben to get into SQL performance goals.
Thank you, Ted. Thanks to everybody first and foremost for attending today. We're going to really walk you through a story based upon our experience with working with organizations from the smallest all the way to the largest around the world, and really bring into this conversation our knowledge and expertise and really what we've seen out there, and compare that to best practice, and so that we can walk away with some actionable recommendations that you might be able to implement within your organization. So when you think about, configuring SQL Server for performance, right? Really, what does that mean? When you think about installing SQL Server, and what are you installing it for? What is the goal? What type of application? And we really want to understand that before we go next on installation. So one of the key things is, what are we installing it for? Are we installing for performance? Is this an application that needs to perform because of its externally facing? Are there any SLAs within your organization or outside your organization? What does it need to scale to? So when you think about scalability, how many users does it need to support? So if I'm installing this on a very small VM, will that be sufficient for the number of users that are going to be using it? So before I make that decision, I need to understand what my priorities are. Stability is a big one as well. So when we think about how we install it, and even also the underlying hardware and infrastructure that we request to install SQL Server, stability is one. And we're actually going to talk about, there's certain settings that directly relate with stability. You might not even think about it normally, but we'll highlight how those settings influence stability. And what we mean by stability is not just up and down of a server, but it even goes into, an application using SQL Server, and then all of a sudden you have a pause. You say, well, where does this pause come from? This pause might come from a certain settings not being set correctly. And we'll go into that a little bit deeper later on. Reliability. When you think about having a production system, one of the first and foremost things, independent performance, it needs to be reliable. Because at the end of the day, whether or not it's 2 seconds or 5 seconds for this response, if the system's up and running and it's reliably giving me my data in a predictable manner, that's usually the first and foremost priority. One of the other key things is, what is going to meet your goal? So when you think about the different types of applications that you support within your organization, there's many different types. Even SharePoint has its own custom settings that ship with it from Microsoft. They actually have the auto update and auto create stats off. And you look at that and you say, well, how did Microsoft determine what those stats are or those configurations are for SharePoint? It basically went into certain testing. When you think about your applications that you support today, what will it take to configure SQL Server to support your applications in an optimal way? We want to know what those goals are. And also, when you think about SQL Server, a lot of times we think about right-clicking on the properties and going into the server properties, or running SP configure within SQL Server. A lot of times, those are the settings that we think about on the top of our head. But at the end of the day, there's also many other configurations that happen at the operating system level that are just as important, that impact SQL Server just as much. And we're going to go over both operating system configurations today, as well as SQL Server configurations. So one of the key things is, best practice versus real world. One of the first things we usually do is we'll search on your favorite search engine, look for, how do we do an installation of SQL, or how do we do this configuration? We're looking for these best practice tips, right? And then, one of the key things is, well, is it really best practice, or is this a blog that is myth and folklore? So one of the key things that we're going to bring to light, hopefully it's here today, is talk about what we've been able to see over our time with reviewing literally thousands of SQL Server instances. And, well, these are also environments that are small to medium to very large, top 5% in the world. And at the end of the day, many of these configurations can be applied up and down the stack. So it's not just a big system recommendation. These are recommendations that should be applied to most implementations of SQL Server. So when we did review thousands of SQL servers, what did we find? Well, one of the key things is, usually DBAs know about 80% of their universe, right? So when we looked at, someone telling us that they know that they have 8 SQL servers, and all of a sudden we found 2 more. This is sort of the classic case of shadow IT, or, other individuals, installing applications to get a POC up. But why is that important? Well, one of the key things is we want to make sure that we're also managing those environments as well. But independent of, knowing your universe, one of the key things is when we looked at the real world configurations, we found that there's many different versions of Windows that we're supporting, and then there's many different configurations. And it sort of went back down to, well, what is your standard build? So when you think about you and your organization, do you really have a standard build today? Or do you have a couple standard builds? And then when do you choose to just install one versus the other? So that's sort of the informal question to you is, think about, do you have a standard build today? When you think about the hardware and OS not customized to SQL, what does that really mean? Think about your process today for asking for a new SQL server. Or, is the application group driving that conversation? So when you think about what is required to support this brand new application that is just getting brought in that needs SQL Server, what are some of the key questions that need to be asked to make that SQL Server optimal? But one of the key things that we found is most of the time you're handed a SQL Server VM or a SQL Server, a physical SQL Server, to put SQL in the application on. A lot of times that is not customized for SQL Server, either at a hardware level, meaning my memory configuration compute is not directly determined by what my use of that SQL Server is, or I get the base operating system configuration for the typical application or file server or any other server that your organization pushes out there. That does matter, because if you think about the block size, when you right click and say format drive, SQL Server would perform more optimally at 64 KB. Well, if you just right click and say quick format, that's going to be at 4 KB. That's just one case where the default OS installation is not optimal for SQL Server, and that's one of the key things that we found when we're reviewing out many of these servers. The other one is servers are not configured the same. So when you think about how many servers are manual versus automated install. So one of the other key things is making sure we understand if we do have an optimal configuration, making sure that we do configure them correctly across. We just worked with a large credit card client where they're very mature, but at the same time, they deployed 3 SQL servers with one as a primary, and then they had availability groups on, or basically SQL Server is always on. Well, all 3 servers actually had slightly different configurations at the operating system level and SQL Server level. So when you think about going back down to reliability of the user experience, that's how the configurations start to impact the reliability. And also just, what do we need to do to support SQL Server to make it stable, reliable, and performant? It really goes back down to aligning these configurations with the workload. So now let's get into the actual configurations. So one of the first things we're going to do is talk about an operating system configuration that most of the time is set to the default that Windows ships with. And this is called, it's a power option. So if you go into Windows and look under power options, you're going to see balanced and you're going to see high performance. But how does this impact you? Think about buying a Ferrari. You buy a Ferrari, but yes, you could drive it fast, but let's say that it's governed. All of a sudden, you're like, well, I have a Ferrari. I can go 200 miles per hour, but I can only go 55 right now because it's governed. Windows, when it ships, it actually from SQL or Windows 2008 R2 and up, it'll ship with a balanced power profile. So basically what it does, the impact is this. There's 2. One is it'll actually turn off cores, and it'll also reduce the frequency. So if I spent a lot of money in buying 3.1 gigahertz processors, I might only be running them at 1600 gigahertz. So all of a sudden, I'm not fully using my processors as far as the number of processors or the speed. And that does matter because when you think about SQL Server, if you have a transactional app, you have a lot of small requests coming back and forth between the application servers. Depending on the volume of those transactions, I might get a slower turnaround time because I process fewer per second because my frequency is reduced. So one of the recommendations is change it to high performance. So, and this is a very easy change to make, and it takes effect immediately. And there's a KB link here as well that better explains exactly what it means and what the risks are. But one of the key things, though, is this is also set in the BIOS as well. The BIOS will override the operating system. So when you get this new, nice, shiny hardware in, many times the BIOS, if you ever hit F12 going to the BIOS, these BIOSes are getting very, very complex as far as the number of options in there. When you go in there, there's really 2 areas you need to look. One is there's power options relating to memory, and there's power options relating to CPUs or processors. You want to make sure that both of those are set to basically high performance. At that point in time, you're going to run both of those at high frequency, and you won't disable cores. At that point in time, you're going to have a more predictable experience. And if you do want to see if whether or not how much the power profile is impacting you, if you go into Task Manager and go into Resource Monitor, you can actually see on the top right-hand side, there's a max frequency up there. It's a scale of 0 to 100. You could actually see whether or not that's below 100. If it's below 100, you're being impacted by this setting. One of the other configurations that we see is policies. So when you think about SQL Server and you go in and install it, there's 2 policies that we want to make sure we take advantage of. One is instant file initialization. So you may have heard about that. Instant file initialization as a feature of SQL Server. And basically what this is whenever I auto grow a file, so if you ever gone into SQL Server databases, right clicked and go into manage the size, and you say, well, actually I'm running out of space. I need to add 10 gigs to my data file. And you click OK. Well, what happens normally? By default, I'm going to wait for SQL Server to zero out the file behind the scenes. Depending on your storage array, that might be 10 seconds, or it might be 60 seconds. Well, that impacts the performance, because if I ever run out of space and I let my database auto grow, all of a sudden I might have a pause. And we have another couple slides later on that show you some of the impacts of those pauses. But what instant file initialization does is it allows me to automatically extend that file without zeroing out. So the risk is very low. There's a slight security risk at some point in time, depending on your vantage point. But at the same time, is the performance is almost instantaneous. The other key setting that we'd want to consider is lock pages in memory. So depending on whether or not you're running SQL Server on a dedicated virtual machine or physical machine, SQL Server uses memory, loves memory. If you're a DBA, you know that more memory is usually better versus less, because basically we cache the data within memory. And when we allocate memory to SQL Server, the operating system by default can trim SQL Server memory down. So if there are other applications, or even if you're running your application locally along with SQL Server, they're going to fight for memory. But let's just say that SQL Server is the most important application on your Windows server. What we want to do is treat it that way and reserve that memory. So lock pages in memory is a policy that basically says whatever you set your max server memory to, okay, or dynamic memory, whatever I grow to, the operating system cannot force and page me out, okay? So when you think about the two things I just talked about, instant file initialization is very important when I'm growing files, especially if I have autogrow and do rely on autogrow. This will help you minimize outages within your application. So the key recommendation here is allocate and grant the perform volume maintenance tasks and lock pages in memory. It's a local policy. So if you go into Windows and just type in local policies, it's under the user ones. And these are the two recommendations we would want to assign to SQL Server service accounts. The next one we want to talk about is really understanding, many times, think about SQL Server. When SQL Server was first launched, they had basically a database engine and SQL Server agent. Well, then they released reporting services, then analysis services, and integration services. So one of the key things is understanding what is installed and what's required to run my application. So when you think about one of the challenges is both what is installed from SQL's perspective, whether it's SSRS, IS, or AS, but also what other third-party applications or Windows features are installed on there as well. Because when you think about each of those features, they all need to be patched. They all use additional resources, whether it's MEM, CPU, other internal resources, and it also increases your surface area attack. So when you think about, security these days, the more features I have, the more ways in. Depending on whether or not you have an older version of reporting services or a newer version, meaning SQL 12, SQL 14, or SQL 8, I might need and require SS or IIS on there. Well, that's a potential attack vector. So the key requirement is really understand what features you have installed and really what they have to take up. If you already had these features installed, disabling them is definitely helpful, but they still should be uninstalled because you still need to patch them. So when you do go to install SQL Server, make sure you are only installing what is required to be supported by the application. So when you think about this, what does this really look like? Down the left-hand side, if you ever go into Windows Server, you can actually see all the different features that are installed. On the right-hand side, you can see the different SQL Server services that are installed. And you look at and you say, well, what do I actually require? So I disabled the services for SSAS on the right-hand side. Well, I still have to patch it. So that's a start, right? But you look on the left-hand side and you say, well, what do I actually need to have installed for me to run my SQL Server? Because many times the Windows team might not know exactly what the application requires, and they'll install more versus less. So always, when you do get your SQL Server, take a look at the services or the feature summary to make sure you understand what's actually running on your SQL Server. So one of the key misconfigurations around this system is when you go to install SQL Server, this is the classic case of where do I put my data files, log files, tempdb, and even system DBs. So when you think about one of the important aspects of what differentiates SQL Server from regular applications, web servers, application servers, file servers usually do not require low latency I/O. What I mean by that is when you go to request some data from disk, the number of milliseconds that it takes to retrieve that data from disk is not as important to web, app, and file servers versus it is SQL Server. So when you think about SQL Server, we need to go and fetch data from disk very frequently depending on the amount of memory that you have. And the latency of that file system is very important because if I'm running a big query, you think about how much data you guys have under management within your organization. So if you have a 100 gig database and you go and look at your largest tables and you say select a lot of data from big table, a lot of that data might not be in memory. Therefore, I need to get from disk. And that's where the slower I/O will start to really impact you. So when you are designing and or requesting a VM or a physical server, you do want to start to talk not just about raw capacity. Hey, I need a terabyte of data. I need 500 gigs of data. You also want to talk in terms of latency, I/O latency, and usually I/Os per second. So the key thing here is for system databases, we want to make sure that the drive's returning data in less than 20 milliseconds. For transaction log, which is basically the very first thing that must happen on any data manipulation that happens, any insert, update, or delete, I need to harden the transaction log. So that's very sensitive to high I/Os. So we want to be less than 10 milliseconds there. And then tempdb, depending on your application, whether or not you do a lot of temporary tables or do a lot of sorts and group bys, you need tempdb, which is write intensive, to also be relatively low I/O or low latency as well. So one of the key things is when you do ask for a certain configuration from your server team, make sure you care about and focus on low latency disks. And when you think about managing databases, so we have default growth properties. And many times when we install SQL Server, we start adding databases and we're off to the races. It's great, right? Well, one of the key things that we do, especially when we manage environments, is we basically flash the server with a certain configuration. And this is one of the things that really does impact organizations, because when you think about, I deploy a database, I don't know what size it's going to be, so I create a shell. So I just say, hey, this is going to be 50 megs. And then all of a sudden I say, hey, Mr. Application, you can start using this. And they start to put a lot of data in there. And all of a sudden, next thing you know, I'm 50 gigs, okay? If I'm growing at 1 megabit per auto growth, how many auto growths will it take to get from 50 megs up to 50 gigs? A lot, right? So that's where this setting comes into play. At the same time, transaction log is set for 10%. So when you think about installing SQL Server and I have a transaction log, if I have a 10 gig, 10 transaction log and I'm going to grow at 1 gig. So remember earlier I mentioned instant file initialization. The caveat with that is that's only for data files. Transaction log files are always zeroed out, and therefore whatever my growth size is for my transaction log, it will wait for the operating system to zero that out. So if you take 60 seconds for my transaction log to grow 1 gig because I just auto grew it at 10% of 10 gigs, then I'm going to basically hold up my application for all activity trying to manipulate data for 60 seconds. And a lot of times that's viewed as an outage. So when you think about the bigger auto growths, that's how it impacts the application. So what's the recommendation? Basically what we do is we recommend first understand what size and capacity my databases are and what they're growing to. So for smaller databases, we usually like to set the auto growth to like 250 megs or maybe 512 megs. Basically something small that I can grow because the rate of data coming in most likely is not going to exceed that value. But if you have databases that are 25 gigs or 50 gigs or 100 gigs, you might want to have the auto grow be at 1 gig or maybe 2 gigs. It really depends on how big your database is, how much data is coming in over a certain period of time. And at the end of the day, it's better to pre-grow databases because then you can control the time at which those grows take place. Because if you are auto-growing during the middle of the day, then you can potentially be impacting the applications. So this is a very good picture. So if you ever go in and say, well, how much do these auto growths actually impact me, right? So if you go into SQL Server, right click on the database, there's a reports entry underneath the tasks. If you go under reports, go to the user reports, there's a database growth or database usage report. These are from the database usage reports, okay? So this is a very good area to see, well, what are the growths actually costing me, right? So if you go under and look at the first option in here, this log file growth for just 500 megs on direct attached storage took 2,900 milliseconds, 3,000 milliseconds. So basically anywhere from 2.5 seconds to almost 4 seconds for a 500 meg growth. So remember, I said even for smaller databases, we might just be doing 250 or 500 megs. Well, that would cause you a 4-second outage. When you think about the file growth for 500 megs, this is on DASD 2, but they're faster disks. It only took 23 milliseconds. And then also on the bottom is, this is a 1 gig growth, and it took 56 milliseconds. So these are basically highlighting 3 different systems with a different growth time for the different types of files. So this is how it can directly impact you as well. So when you think about some of the other features that Microsoft provides you, 2 of them, auto update and auto create stats, and also auto shrink, okay? So when you think about the different properties on the database, some of them are good and some of them are not as good. So when you think about auto shrink, right? Auto shrink is nice because as soon as I am done using this space and have some space freed up, it shrinks it back down. But if I go back and I look at this slide, I say, well, what's the cost of growing a file? On that top one for growing a file 500 megs, my cost is 4 seconds for 500 megs. So if I am auto shrinking it, and then I'm auto growing it the next day, that's my hard cost right there. So I want to be very careful about when I would use auto shrink. We always have it off, right? We have not had a time where we have it set on the database level. If we do have a need to reclaim space, maybe you do a one-time a month batch operation, we basically create a customized process, a SQL Server agent job that will manage the shrink and then also pre-go the database at a time when the batch process is not running. Because what that does is it's a predictable planned event that I can control. Auto shrink is a opportune unit. Basically, it takes the first opportunity to shrink it when there's free space. So we also want to make sure that auto update and auto create stats is not disabled as well. Now, if you are supporting SharePoint, these will be disabled. But on most other, like 99% of the other database products that you guys support out there, we want those created because when SQL Server is optimizing and executing a query, one of the first things it does is look at statistics because that's basically you going to Google. And with Google these days, ever since they bought Waze, they look at the traffic patterns and they say, how is the best way to get to my destination right now? Based upon traffic, based upon routes, based upon road closures, how do I get there? Stats are the same thing that drives the best way to get to my data for SQL Server. So one of the key impacts of auto shrink is it increases fragmentation. It's a very costly operation, both not only on I/O but CPU, because I'm basically having to manage these processes to go. So the key recommendation is disable auto shrink. And one of the key things, as well as there's capacity planning, is really just plan for 6 months of gross. And many of us will say, well, that might be a lot of data, but at the same time, if I'm going to need it now or need it within 6 months, I probably need to make sure that I at least have it. So even if I'm not planning for 6 months, I'm planning for 3, you still need to ask the question, why shouldn't I be planning for 6? Because if I have to order a new storage array because I'm almost out of space, that's usually needing a long lead time. So make sure that you're letting your organization know and plan for 6 months. Monitor the growth rates over time. It's an interesting question. When I do speak at different events, one of the key questions I ask is, well, how much did your data grow last year? Depending on you and your information, you may not know the actual details of that. Most people know how much data they have versus the growth method. But the data these days is only increasing in growth versus decreasing. So it's very important that we do plan for that. And statistics. Updated stats yield better execution plans and better weights to the data. The same as Google. So if I'm using yesterday's traffic at 12 to get me to a destination today at 5 in Charlotte, then that's going to impact my route because it's not up-to-date statistics. One of the key things that we'll see, and we understand why this happens. So databases with multiple transaction log files in separate drives. So many times this is a result of us running out of space on a drive and us not being able to shrink that transaction log. So therefore we add another transaction log to another drive. Well, SQL Server does not stripe data across multiple transaction log files like the data file does. So when you think about multiple data files, SQL Server uses proportional fill algorithm. The transaction logs does not. It's a sequential process. Okay. So if you do have multiple transaction log files, they're not benefiting you from a performance perspective. Okay. So our recommendation is basically for each database only have one transaction log file. And again, size appropriate and pre-grow. Pre-growing the transaction log file is probably one of the most important activities because that is the first activity that is done when you start to manipulate data. If you don't have space within your transaction log file, that's basically an outage. Another one is the max memory. So when you think about SQL Server, you think about configuring, you just got a SQL Server that has 32 gigs of memory. One of the first questions is a very challenging question too. Well, how much memory do I allocate for SQL Server? Well, SQL Server by default ships with something called dynamic management, or basically dynamic memory. If I don't set max memory, SQL Server will manage the memory for me. Well, that's great. But here's the classic situation. So let's take your organization where you may have some dedicated SQL servers, but you also have that one SQL server that shares it with an app server. Okay. So you start up SQL Server, you start an app server, people start using both, right? Your application is going to start to consume a certain amount of memory and compute. SQL Server is going to do the same. So as you basically prime memory, which is basically I'm reading data within SQL Server, that data is going to sit in memory and won't be paged out until I need to be paged out. And it will be paged out based upon a usage algorithm. But if I have 32 gigs of memory, guess what SQL will do? It'll actually try to use up as much as possible. Well, the operating system needs memory. FireScan needs memory. Other processes need memory. Your third-party application needs memory. So all these applications on there are going to compete. And that's where the only way to really gate and provide SQL Server with a guaranteed set of memory is by setting max memory. So even within instances where I can have, or servers where I could have multiple instances of SQL Server. So SQL Server back in 2005 allowed me to install multiple separate SQL servers on the same server. Those are called instances. Whenever I do even have multiple instances, I will still set max memory. Dynamic memory works pretty well, but you're not guaranteed anything. And I could have one big query come in from one other SQL server that basically balloons that memory and hurts another SQL server. So if anything, I do like to gate and control my memory per SQL Server instance. So when you think about what do we set it to, there is a blog by Jonathan Cahias that helps you understand all the different variables that go into SQL Server memory configurations. But the key thing with this is what we're doing is basically setting a ceiling, because the last thing we want to be able to do is starve the operating system or third-party processes of memory and have them start to be paging out, just because we want a little bit more memory to be somewhat healthier. If you truly need more memory, and before you set max memory, or even when you set max memory, one of the best things that I would recommend is if you ever use perfmon. Perfmon is a native Windows tool, and it allows you a lot of great information. Or if you have third-party monitoring tools, go in there and check your page life expectancy and your buffer cache usage as well. Those will help to tell you how healthy you are with the memory that you have allocated for SQL Server. Because there's many instances where I see SQL Server configured, we'll just say to 16 gigs, and I actually have too much memory allocated to SQL Server. Well, why is that a challenge or a problem? Well, if you're hosting multiple SQL servers, maybe you have another SQL Server that could use some of that memory because it's under memory pressure. So I always like to right size my environment. So even if I do have over healthy memory, always think about right sizing and the other applications you're supporting with your organization. So one of the last misconfigurations is untrusted constraints. And realistically, what are these? These are when you have a parent table and a child table, and the parent table has a foreign key to the child table. So what you're doing is saying, my data in my child table must exist in my parent table. Well, many times through migrations, etc., people will drop those foreign keys to add data because they want to bulk load some data. And when they add the constraint back, they add it back without checking the existing data. Well, why is that a problem? Well, it's a problem within SQL Server because whenever I go to insert, update, or delete data within my child table, I need to now scan my parent table to make sure that that data does exist. If I'm in an untrusted constraint situation, that's an extra activity every time I query my data. So we want to be able to make it a trusted constraint so that we can prevent an extra scan of your parent table. Therefore, your performance is better. Now, many times these alter table statements are generated out of a third-party tool. The key thing is before you check, a lot of times there's properties in there for generating DDL. Check to make sure that it's checking the constraint. It is odd in syntax. It does look incorrect, but that's how SQL Server validates that the check constraint is checked. So this is a very important configuration, and it's sort of a hidden one as well, just because usually you're not looking at the foreign key constraints and whether or not they're enabled or not as far as trusted. So having the constraints helps you save additional workload. So one of the key things is, when you think about what we just went through, these are some base statistics that we talked about just upon our experience within the industry. But it all started back when we were able to pull and review our settings across our organization. So whether or not you have one SQL Server or 10 SQL servers, what we would recommend is really collecting this data, the metadata and the runtime data across your systems. The reason why I mentioned runtime data is this, because how you configure SQL Server is really determined by the workload and the runtime data. So if you have a lot of queries that are reporting and oriented, you might want to configure max DOP higher. Okay, that's max degree of parallelism. If you are doing transactional environments, you might want to configure my memory a different number as well. So it all starts with understanding what you have today. Once you understand what you have, what type of applications you're supporting, create a base configuration for your environment, because that really helps standardize and make your life a lot easier on support. Because if I know what the base configuration is for all my SQL servers, whether it's file paths, drive names, SP configure values. It helps me support that implementation. But at the same time, as you might have multiple base configurations. Here's a classic example. SQL Server has availability groups now. Basically, I can mirror data to another server. Most organizations will use that for high availability or a secondary reporting server, which is great. If I'm only doing transactional data and traffic on my primary server, I'm going to have a certain workload there. So I'm going to have a certain configuration. If I'm running an analytical or reporting workload on my secondary server, I'm probably going to have a different configuration. So you might have multiple configurations based on the type of workload or activity that you're going to run on it. Also, make sure whatever base configurations you apply. So when you deploy SQL Server and you deploy a brand new database and you want my recovery model to be a certain way. I want my auto growth settings to be a certain way. I want my minimum file sizes to be a certain way. All these are stored on the model database. So every time you say right-click new database, it's actually created from the model database. So whatever settings you do want to modify, apply them to the model database, and then they'll be applied to your databases. The only time that doesn't happen is if you do a restore from another server, it'll take the database settings from that other database on the restore and apply those. So it's only on the new database that it takes from the model. The restores keep their existing settings. And at the end of the day, whenever you are given a new server, please verify and validate that the OS configuration and even the other applications that are installed on there as well are what you expect. I usually end up creating a quick PowerShell script that goes through and says, hey, what's my power options? What's my local policies? What's my disk format? And that helps me understand exactly what I was just given. Because if this is going to be a system that I'm going to be supporting over the next couple of years, I want to make sure that I basically know what I'm supporting and know what I bought. So that's the end of the presentation. I'm going to hand it back to you, Ted.
Good job, Ben. So, now you guys have some very tangible things that you can go take a look at with your existing SQL Server instances, and hopefully you'll be more prepared the next time you need to provision a SQL instance. At the end of the day, there's a lot underneath the hood. SQL is a very complex animal, and there's no substitute for experience. So while we wanted to give you some tangible things to look at, at the end of the day, we're still here to help. So we have a product called SQL MD, and if you want to have a current state analysis, Ben, if you can go to the next slide there. If you want to have a current state analysis of your existing SQL environment, it's a very low-cost, fixed-fee engagement where we can come in and evaluate all of the settings we talked about today, as well as many others, and compare those against best practices, and give you some very tangible things that you can do to improve all the ilities, stability, performance, reliability, and those sorts of things. So please reach out to us, info@acrowire.com, and let's go ahead and jump into Q&A. And Gail, I'll go ahead and field these. So it looks like Ben started to answer a few of these, but so everybody has visibility into what we're responding to here. Ben, Evan says that TDE does not support instant file initialization, and his firm uses TDE on all their databases now. Could you comment on that?
Yeah, so as Evan had pointed out, there's certain settings depending on what feature you're using within SQL Server on what it supports and what it doesn't support. So these recommendations are based upon the generic SQL Server implementation. But if you're using a customized feature like TDE, you may not be able to use certain features. This is one of those edge cases where you're not able to use the instant file initialization. but like block pages of memory, auto growth, capacity planning, all those other processes or methodologies still apply to how you would manage that as well.
Okay. So the next question is from James, and James asks, do the power options still impact CPU in a virtual environment? My understanding is that NetWare, and in our case Cisco, have tighter control over the hardware.
So that's a good question. So when you're using UCS and then other third-party products, so you think about the layers in the cake. So all of a sudden you have your hardware, then you have your hypervisor on top of that, then you have SQL Server and operating system on top of that. So at the hardware level, basically, your BIOS is still directly impact what you see within your VMs. So even if I have my power options set correctly or incorrectly within my operating system, I'm still bound by what my BIOS is set within UCS, HP, Dell, or whatever the flavor is. So it does impact you even within a virtual environment. And the easiest way to see this directly is if you go into perfmon, there is an object counter called processor information. So processor information, under there, you can see lots of different object counters. There's a % of max frequency. It's very interesting to look at. So if you want to see what frequency your processors are actually running at, even in a virtual environment, go in there, processor information, max frequency. The other one I didn't mention, but if you're in the BIOS, it's just important as C states. So if you're running a production workload, C states is basically a certain power state of the processor. So if you are running production workloads and you see anything but C1 states, you want to disable C states in your BIOS as well. So both of those would be directly correlated to both physical and virtual implementations.
Okay, so then we have two other questions that are related, and Gail, we'll need your input on this. And the questions are, can we get copies of the slides, and will this presentation be available as a recorded session?
Yes, on both. The recording and the copy of the PowerPoint's presentation will be posted to our website probably in about 2 or 3 days. Okay, so I would say by Monday of next week.
Okay. Excellent. Any other questions? Those are all that we had queued up at the moment. Okay, Gail, looks like that's a wrap.
Okay, well, Ben, Ted, thank you for the presentation, and Acrowire for sponsoring. Everyone, thanks for attending, and just keep an eye out for future webinars. So everyone have a great day. Thanks, everyone.
Thanks, everybody.
Oh, wait, Ted?
Yes.
Oh, no, never mind. I thought we had, we do have another question. I don't know if you answered that one.
Let's see. So the only other question there is, will the slides be available?
Oh, okay. Yes, they'll be available. All right, everyone, have a great day.